So today we will see an interesting geometrical problem. First of all, let me explain you this question and then we will proceed for its solution. So the main clear diagram is over here. Let me make you a rough diagram how the question is to be explained. So suppose you take a semicircle, and taking a semicircle is easy. Then you take the center of the semicircle. Now we take a triangle like this way and join a line from the top of the triangle to this center point. Now you fit two circles such that it is tangent to all the three sides of this triangle and the other circle is tangent to all the three sides of this triangle. And now the question is, if the radius of the first circle is 9 and the radius of the other circle is 8, then what should be the radius of this semicircle so it fits these two circles in this particular pattern? Okay, so I hope the question is understood, and now let us proceed for the solution. You can just pause the video if you want to give a try to this question. Okay, so who have tried the question, they can now check the solution with mine, and those who have no idea how to do it, let's see and learn how to solve this. So first of all, let us talk about the theorems that we are going to use. So the first theorem that we are going to use is this one: angle inside a semicircle. Angle inside a semicircle is always 90 degree. Now what this is says is that if you have a semicircle and these 2 points are the endpoints of the diameter, if you make a triangle such that the head rests on the circumference of the semicircle, then this angle is always 90 degree. The proof of this theorem is also very simple. You can just Google it, or you have already learned this thing in the schooling time. It's simple. It comes from this parent theorem. That the parent theorem is also interesting. It says that in a circle, the angle subtended by the chord at the center is always double the angle subtended by the same chord at any point on the circumference. It says that if there is a chord AB and if that chord is subtending an angle alpha at the circumference, that the same chord will subtend an angle 2 alpha at the center. Now what happens is that when we make this chord closer to the center, eventually 2 alpha comes closer to 180 degree, as we can see, and as this center angle is 180 degree, the circumference angle has to be its half, and ultimately it becomes 90 degree. The proof of this thing is also very easy. There's no need to explain that in this particular video, or the video would be very lengthy. So this theorem we are going to use. So now everyone can now clearly see that this theorem is going to be used to mark this angle as 90 degree. So in this particular diagram, let me use some different color. Green color would be okay. Not green color is also not visible. Let's take black only. Okay, so this angle is 90 degree. Okay, this is just because of the theorem that we just discussed. This point is A, this point is B, and this point B C. The center, let it be P. Okay, now let us talk about the other theorem that we are going to use. The second theorem is also very simple. You have also learned that is tangents drawn tangents drawn to a circle, tangents drawn to a circle from same point are equal. Now what this theorem says is that if there is a circle and you choose a point A, from that point A if you draw one of the tangent, and from the point A if you draw another tangent, say T and M point are the point of contact, then the length AT would be equals to the length AM. So from this, the theorem is the statement that two tangents drawn to a circle from a same point are of equal length, or we say that tangents drawn to a circle from the same point are equal. Two tangents drawn to the circle from the same point are equal. The proof of this is also very easy. This is the center O. We know that tangent and radius meet at 90 degrees, so this is 90, that angle is 90, and suppose we draw this line. So we can see that this triangle is congruent to this triangle by which property? It's basically by right angle common hypotenuse, and these two sides are equal because they are the radius of the same circle. So as these two triangles are congruent, the remaining things become equal, and hence this side is equals to this side. Okay, now let us use this particular theorem in our question. So we can see that from this point P we have a let us just talk about this blue circle first of all. So from point P we have a tangent, this and this. From point A we have the two tangents like this way, and from point B we have two tangents like this way. So let me just draw this thing as a separate at this side. So suppose we have the triangle like this over there, and inside that we are having this blue circle. So okay, inside this we have a blue circle that is tangent to the three sides. Okay, this point we have marked as A, this point as B, and this point as P. Now from the second theorem we just saw, this length would be equals to this length. Let us suppose this length is equals to A. These two lengths would be equal, let it be B and B, and these two lengths would be equal, let it be C and C. Okay, this thing is very understood. Now look carefully in the diagram. As I told you that P is the center of the semicircle, so it is clear that from the length PB, this length P to B would be same as the length P to A, because they are the radius of the same circle, because they are the radius of the same circle. So hence in this diagram also we can say that from the bigger semicircle, the perspective is of the bigger semicircle. From the perspective of the bigger semicircle, PA is equals to PB, radius of the same circle. Now look carefully, if PA is equals to PB, we have that A plus B is equals to A plus C, cancelling out the A gives us the result that B is equals to C. Hence this C would be simply as B. So we'll just not use the C variable from now onwards, we'll continue with B. Now the same thing can be done with this pink triangle also. Let us talk about that arrangement also. So the arrangement of the pink triangle is like this. We have taken another diagram as a reference. Now this is the pink triangle, sorry, the pink circle inscribed in it. The points are marked as B, capital, sorry, this one was the center, it was capital P, and this is the capital C. Okay, now as this point P, from the point P we have two tangents, these two would be equal, so let it be D and D. Similarly this and this would be equal, E and E, these two would be equal, F and F. Now again from bigger semicircle, now from again the bigger semicircle, perspective of the bigger semicircle, we again have that PB is equals to PC, because they are the radius of the bigger semicircle. And if these two lengths are equal, then we'll again have that D plus E is equals to D plus F. D will cancel out, E is equals to F. So we'll not use the variable F, as it is again equals to E. Now it was clear now that PB was equals to PC, because they were the radius of the bigger semicircle. Okay, now up till now we have just done some this kind of rough markings of the side lengths. Now let us mark some of the angles. Okay, now let us mark some of the angles, so we can make a reference that from this diagram we have taken out this blue side triangle over here and that pink side triangle over there, so don't get confused. Now in this diagram let us mark a few things. If I mark this particular angle as 2 theta, what can you say about this angle? So remember that PA was equals to PB, so if two sides of a triangle are equal, now let me write down the third theorem that we are using. The third theorem is angles opposite to equal sides are equal. Angle opposite to equal sides are equal. Suppose that we have a triangle, and if these two sides are equal, it is clear that these two base angles would be equal. Okay, the proof of this thing is also very easy. All you need to do is drop a perpendicular from here, right angle, these two triangles will become congruent by right angle hypotenuse side, and you will get the thing that this angle is equals to that angle. So as PA was equals to PB, if I mark that angle as 2 theta, this will become 2 theta. Similarly, if I mark this angle as 2 alpha, this angle will become 2 alpha. Okay, so in this diagram also let us mark that thing. This is equals to 2 theta, this is equals to 2 theta, and I am taking this one as 2 alpha and this one as 2 alpha. Okay, up till now all good. Now again looking back at the diagram. Now recall that we have just seen that this length was B, this length has also come out to be B. So if I just take the complete triangle PBA, just looking over here, I have just taken that triangle out. Look at this triangle PBA. What you can see is that first of all, PA is equals to PB. First of all, you can see that PA is equals to PB because they are the radius of the same circle. And this point of contact of this blue circle with the side AB is such that it is bisecting the side in equal lengths B and B. Okay. Now also recall that if I mark this as the center of the blue circle, I will have the radius perpendicular to this particular point. Okay. So what I can see is that I have a triangle arrangement like this way. First of all, these two sides are already equal. Now here is the bisection point of the base B and B. From the center of the circle, I have a perpendicular dropped over here. Now I also know this particular thing, that is, in an isosceles triangle, the perpendicular bisect the base. Means if I draw a perpendicular from this head point to the base, it will bisect the base. Now combining these two information, what I can conclude is that from P, if I drop a perpendicular, the center of this circle will lie on it. It is obvious, okay, because we cannot have two such points. These two base points must be equal, and if they are equal, then the center of the circle will lie on this altitude only. Okay, now the similar thing can be done in this pink side triangle also. As these two sides are equal, what we can see is that if I drop a perpendicular from this, it is bisecting the base, and the same property is done from this particular point, that if the from center of the pink circle I draw, if I join this point of contact, then because of the theorem the radius would be perpendicular. So combining the fact, we have that the center must lie on the circle, sorry, must lie on the altitude dropped. Now inside this diagram, if you draw this particular thing, it will come out to be like this way. Using the green color, we'll have a straight line from here to here, and again we'll have a straight line from here to there. So this would be 90 degree, this would be 90 degree. Okay, and recall that this angle was already 90 degree because it was the angle inscribed in a semicircle. Okay, now what we can observe is that we have a four-sided figure over here in which the three angles are already 90 degree. So by basic angle sum property, this fourth angle will come out to be a 90 degree again. So you have a quadrilateral in which all the four angles are 90 degree, hence it is a rectangle. It can be a square, but basically it would be a rectangle. And if it is a rectangle, in rectangle always remember the opposite sides are equal. So look carefully, this length is equals to b, hence this length would be equals to b. This length, as we have seen, was marked as E, so this length would be marked as E. So now let us mark this length in our diagram. So we have seen that this length would be marked as E and this length would be marked as B. Okay, no confusion till now, it should not be. Sorry, as we have taken some yellow and white diagram, next time we'll take care. Making videos after a very long time, now we would be regular, so sometimes this kind of mistakes happen. Okay, so yes, the length from that B has dropped, has given us the length of this particular altitude, and we have also got the length of the altitude of this green as E. Okay, now the fact that we have just discussed so long that the center must lie on the altitude will now help. Recall that this blue this blue circle was having a radius 9, hence this length from here to here is equals to 9. The complete length is equals to E, hence the length from here to here would be simply E minus 9. Okay, now the similar thing over here, the complete length is b, this is the radius having a length 8, hence this length would be b minus 8. Okay, okay, good. Till now we are going good. Now let us discuss about these angles, that 2 alpha. Till now what we have did is just side length, side length, side lengths. Now let us discuss few of the angles what we have marked. So the first thing that we can see is that top angle was 90 degree because of this particular theorem, and at that same point we have marked 2 theta and 2 alpha. So from there we can conclude over here, at point, the top point is basically we have seen as point B. So at point B we have that 2 theta plus 2 alpha is going to be 90 degree. Hence we have a relation that theta plus alpha should be 45 degree. We'll use this later on. I am just leaving this space over here. We are going to use this, and it's a very important thing over here in particularly my solution. It's something nice that someone's solution may not include this, but in my solution it's playing an important role. Okay, now let us talk about other things. So over here, this angle is equals to 2 theta. If I drop a perpendicular, let me just remove this length E. You have to remember that this was E. Okay, if I drop a perpendicular over here, means basically I drawn the radius to the base, so it has to be made at 90 degree because this line is tangent. We can see that here we have got two congruent triangles, this one and this one. This kind of arrangement is very famous, and hence by congruency 2 theta will split as theta and theta. Okay, and similarly in this particular side of this pink circle triangle, if I draw the radius, it will meet at 90 degree. And again we have this famous arrangement, this triangle congruent to each other by a right angle hypotenuse side, and hence the 2 alpha will split as alpha and alpha. Okay, nice, something nice we have got. Now recall that, again going back to the diagram, see that let me change the color. This angle is 2 theta, this angle is 2 theta. So now the third property, not a third property, it's not even worth to write over here, but let us write the external angle property. Now what this the external angle property states that is that for any particular triangle, if the two internal angles are A and B, then this outer angle can directly be the sum of the interior two opposite angles, A plus B. It's very simple and easy to prove. All you have to do is take this angle as C. Angle sum property will make this angle as 180 degree, then you have this value of C as 180 minus A minus B, and if you have a linear pair with this particular angle marked as D, you will come to the result that D is equals to A plus B. It's very simple. Okay, just forget about that. So this angle is 2 theta, this angle is 2 theta, so by exterior angle property we have just discussed, this angle would be 4 theta. Similarly, this angle is 2 alpha, this angle is 2 alpha, this angle would be 4 alpha. Let us mark this thing clearly in our diagram. So from this particular 2 alpha and 2 alpha from the pink triangle has helped us to get this angle as 4 alpha, and this 2 theta and 2 theta from the blue triangle has helped us to got, oh this very congested over there. Let me just elaborate, means zoom out the point P. This angle is 4 alpha. Okay, now see that we have the pink circle as a tangent from this side. Sorry, just make it clear. The pink circle is tangent to this side also and this side also. So again I will draw the radius, and again I will draw the radius over here. Again I will have this famous arrangement, and this triangle would be congruent to this, and what I will see is that 4 alpha has been splitted as 2 alpha and 2 alpha. Sorry, not this angle was not containing alpha, my mistake. This in pink side triangle we were having 2 theta that the neighboring blue triangle gave. Okay, sorry, blue circle triangle gave. So this angle was 4 theta, and because of this famous arrangement this triangle is congruent to this triangle. Hence we will have 4 theta splitted bisected as 2 theta and 2 theta. So what we have made a conclusion is all that this particular angle over here, this blue angle over here, is equals to 2 theta. Keep this thing very important. Okay, now similarly over here this one is a bigger triangle, hence nice. This angle we have got as 4 alpha. Again this is radius, so 90 degree. This triangle congruent to that triangle, right angle hypotenuse side. A famous thing, 4 alpha will split bisect as 2 theta and 2 theta. Let me make this as a small eraser. Okay, so we'll have 2 theta and, sorry, 2 alpha and 2 alpha. So this particular angle over here will have this thing as 2 alpha. Okay, very nice things going on over here. Now let us talk about few things. First of all, you can just have a look at this particular triangle over here. Let me just make this triangle outside in the blue color, so you'll have that we are talking about this. This angle is 2 alpha. Okay, what can you take about the hypotenuse? We have already found it as e minus 9. What about the base? It is equals to a. And what about the hypotenuse? It is the radius 9. Okay, now let us talk about this particular triangle that we have got over here, this one. Okay, as you can see, this particular one. So this angle we have got as 2 theta. This is 90 degree. The base is d. The hypotenuse is we have found b minus 8, and the height is already equals to 8. Okay, now this two right angles triangle is very clear to you. Now let me introduce one more right angle triangle, and you have to figure out from where it has came. So I am talking about this right angle triangle. This length is 2b, this is 2e, this is 2x, and this is a, b, c. Okay, we have not yet mentioned, let the radius be equals to x. Okay, so if the radius is x, the complete length would be 2x. We have just found that this was b and this was b, hence the complete is 2b, and on the other side this is e and e, so it is 2e, and this angle is right. We have taken the biggest right angle triangle from this tag, and we have also seen that this angle was 2 theta and this angle was 2 alpha. Now let us combine all this thing together. First of all, talking about this biggest white right triangle, you can say from that triangle what is the value of sine 2 theta? It is going to be opposite upon hypotenuse to 2c upon 2x. 2 and 2 cancel, we have c upon x. Now again we have 2 theta. Yes, it is in the pink triangle. So according to the pink triangle, what is the value of sine 2 theta? It is going to be 8 upon b minus 8. So we can just compare these two, because sine 2 theta are equal, and hence we'll have c upon x equals to 8 upon b minus 8. Cross multiplication, cb minus 8b is equals to 8x. Okay, nice. Now in the similar way, from the white triangle we have sine 2 alpha, and it is equals to 2b upon 2x. 2 and 2 cancel, we have b upon x. And from the blue triangle we have sine 2 alpha equals to 9 upon e minus 9. So comparing these two, as we have compared there, over here what we will get is b upon x equals to 9 upon c minus 9. Cross multiplication will give us cb minus 9b equals to 9x. So we have this two particular equation, and let us solve it twice in the two different manners. First of all, we have 9x equals to cb minus 9b, and the other time we have 8x equals to cb minus 8. If we'll just subtract this two equation, we'll have x is equals to cb, and cb cancel out. Negative 9, sorry, we have taken b twice. Wait, it's going to be 8c over here. My mistake, 8c. So it's going to be 8c over here also. Okay, so negative 9b plus 8c. Hence finally we have this first relation, important relation. The first important relation that we have reached is that 8c minus 9b equals to x. Means what we have done is two variables b and c that we have marked that were important, as they were something like, wait, how come c has come? Oh, it's 2e. Wait, again my mistake. It's 2e, not 2c, it's 2e. Sorry, so many mistakes making videos after too long. It's e, b, e. It's not c, it's e. So basically we have removed c in the starting only. So it's 2e. Yes, it's 2e. It's 2e. Yes, I have told before also it's 2e. Here also I have written 2e, but in the sign we have taken c for mistakes. Really sorry for that. 2e upon 2x. Yes, yes, yes. Okay, now all things good. Okay, so this thing we have got. Now what to do further? Now look carefully. As we have seen, this yellow triangle we can see. Here we have this yellow triangle. Now this one is having an angle theta. Now this is very interesting. Sometimes we have theta, sometimes we have 2 theta. Just be careful with that. So what we have is this yellow triangle, and in that we have this angle theta. So if that is the angle theta, can we have some values? Yes, we can have the value of tan theta. What it is going to be? The height is 9 and the base is b. And the similar way, in this yellow triangle on that other side, we have angle alpha, and the height is 8, radius of the pink circle, and the base is e. So we also have the value of tan alpha, and that is 8 upon e. Okay, now I'll not make the mistake of c and e. Okay, so as we have written this thing close to this thing, you have just guessed we are going to use this particular relation. So we have theta plus alpha equals to 45 degree, hence theta would be 45 minus alpha, hence tan of theta would be equals to tan of 45 minus alpha. So tan of theta, this relation is basically the identity. So tan 45 minus tan alpha divided by, sorry, not it's going to be uh, 1 plus tan 45 into tan alpha. So tan theta, what is the value? It's 9 upon b. Tan 45, 1 minus 8 upon e divided by 1 plus 8 upon e. So we'll have 9 upon b is equals to e minus 8 upon e plus 8. Cross multiplication will give us 9e plus 72 equals to eb minus 8b. Hence 9e plus 8b plus 72 is equals to eb. Okay, this thing is important over here. Now as I told you that these two green equations that we have got, we are going to solve it twice. Let us do that. So we were having 9x is equals to eb minus 9b, and we were having 8x equals to eb minus 8e. Okay, now what if I just get some relation between e and b, and to do so we have to eliminate x. So to eliminate x, I will multiply this by 8 and this by 9. So we'll have 72x equals to 8eb minus 72b, and 72x equals to 9eb minus 72e. Now I'll just subtract this two equation. This will get cancelled out. 0 equals to negative eb. This will become plus 72e minus 72b. Hence what we'll have is 72e minus 72b is eb. Now here we have the second important relation. Now what I am planning is to substitute these two equations together, means just make them combine together and solve for either of the variables. And to do so I have to just use the substitution method. So from this equation, let me just eliminate the variable e, as I am getting confused in that only. So what we have is 72e minus 72b is equals to eb. Okay, hence 72e minus eb is 72b. Hence e taken common out will 72b upon 72 minus b. This is the value of e. A little complicated as the number is 72 bigger, but don't worry, we have to just deal with it, and it's just going to be easy. Now substituting this value of e in this particular equation, hence first we have 9e. So 9 times 72b upon 72 minus b plus 8b as it is plus 72 as it is, then it is eb. So the value of e is in this box, we have to just multiply b. So 72b square upon 72 minus b. We have to take the LCM on the left hand side. First of all, 9 into 72, let just be 9 into 72 into b. Will not solve that. 8 into 72 as it is minus sorry, it's 8b, so it would be 8 into 72 into b. Then we'll have negative 8b square. Then we'll have 72 square minus 72b, resulting in 72b square. The denominator will simply get cancelled out. Now we can see we have dealing with a quadratic equation. Let us make this together, shifting all these things, just rearranging. So 8b square 72b square will result in 80b square. Then we have these two b terms. So I can see that 8 into 72 into b minus 72b. So it's basically 7 into 72b. And as we have shifting this thing, this will become negative 7 into 72 into b. And then we have, sorry, we again have one more b over here, and it is sorry, let us just, it is 972b, 872b, and negative 72b. So 8 plus 9, it's 17, 17 minus 1, it's 16, and it is moving on that side. So we have negative 16 times 72b and plus 72 square, and this thing is resulting in 0. First of all, what we can cancel out is from the table of 8, 10b square minus 2 into 72b plus 1 of the 72 from the table of 8 will become 9 into 72, and that is 0. Can we again cancel out? Yes, from the table of 2, 5b square minus 72b plus now we have this thing as 9 into 36, and that is equals to 0. Okay, yes, 5b square minus 72b plus 9 into 36 is equals to 0. Now let us solve this, and we can just use quadratic equation. First of all, let us see what is 9 into 36 resulting in. 9 into 36, we have 9 into 6 as, sorry, like this way, 9 into 6 is 54, and it's 324, 324. Okay, okay, now it's getting us, you are also getting some hope that we can solve this. So we'll use the quadratic equation. B will come out to be 72 plus and minus square root of, as 72 we have already got, plus negative of negative, the formula you all know that b would be, sorry, not b, if we have any standard equation of this particular pattern, ax square plus bx plus c equals to 0, then x is negative b plus and minus square root of b square minus 4ac upon 2a. Quadratic equation, let us use that. So negative of the middle term, it's negative of negative 72, 72, then we'll have 72 squared. So 72 squared, let us do that. 2 2 4 7 7 49, 7 2 14, 14 2 28. So it's 4 8 1 and 1, 5 1 8 4. Then we'll have negative. Should we have negative? Yes, there's the mistake. Here's the mistake. As we have shifted 72, it should be negative 72. Okay, so negative negative positive will become 4 into 5 will give us 20, and 20 into this thing will give us 8 4 6 6 4 8 0, and in the denominator we'll have 2 into 5, basically 2 into 2a. The denominator is 2a, so here we have 2 into 5, that is 10. So b is equals to 72 plus and minus. Now this thing over here is resulting in 4 6, 1 shifted, so it's again 6, 5 and 6 is 11. Is it 2? Yes, we are getting something like 11664. Let us find the square root. 2 2, 1 into 1 is 1 0. We have 16 down here. 1 plus 1 is 2. 16 will not come, so 20 into 20 I have to do. Nothing will come. 1664 has come down, so something that makes this, is it 8? Yes, it is 8. 8 6 in, is it 8? 8 it's a 64. Yes, it is 8. So the answer of this square root is 108, and in the denominator we'll have 10. Finally b will come out to be, we cannot take negative as b is some side length, so 72 minus 108 makes no sense. We'll just have to add it. So we'll have 180 upon 10, and hence b is equals to 18. What a nice value after this quadratic equation. Now recall that E was equals to this thing. So as B is equals to 18, the value of E would be 72 into 18 divided by 72 minus 18 results in 54. Now from the table of 18 itself, it is 1 and it is 3, and from the table of 3 it is 1 and it is 24. So B is 18 and we have got E as equals to 24. Now recall this particular green equation that we have the value of X. So X is equals to 8E minus 9B. So 8 into E and 8 into 24 minus 9B and 9 into 18. X is equals to. Now look carefully. 8 4s are 32, 2 and 3, 192 minus 9 into 18. 9 into 8, 2 and 7, 162, and 192 minus 162 gives us the answer 30. And this is the final result, that the radius of that particular semicircle has to be 30 to fit these two circles of the radius 9 and 8 in this particular arrangement. Now what I am thinking is, what if the radius was A and B in general, then what can you say about X? Can we say something about that? I have also not thought yet. I am just sitting to make this video and I am thinking. So what I am thinking is that from the particular method that I followed, the numbers given were such that the quadratic equation on all the things came out to be very nice. For some random numbers a and b, it might not be very nice to solve like this way. But I hope you like this solution, and whatever your suggestions are there, do comment it below, and the email is still active. You can drop a mail or you can just comment whatever the queries are, and I'll promise that I'll meet you from now onwards daily with this kind of geometrical and mathematical problems. Thanks for watching. Bye bye.